All right, we got to do some matching here. So remember, when you see something, when the x is squared, that's a quadratic. Quadratics come out as our u-shaped. Okay, so we've got two of those. All right, so when the number in the front here, all right, the coefficient there is positive, it opens up, so that's e. The bars are absolute value bars. Those come out as the v shape. Looking at the x, the exponent is just 1, so that's a linear, okay? And it has a negative slope, so that's f. Y equals 3, okay? That has you can think of that as a 0 slope, so that's horizontal, that's a. Number 5, the variable is up in the exponent, so that's an exponential function. Okay, so that's right here, c. And here we also have a quadratic. It's squared, but it faces downwards with the negative coefficient here, so that is d. All right. So let's come down here telling whether something is a function or not. So we have graphs, and we have actual equations here. So this is a straight line, and it passes the vertical line test. So that is yes. B is not a function. You can see it hits, if I draw a line, it hits 2 spots vertically. That's a no. That's a yes. This passes the vertical line test as well, so that is a yes. Y equals 5x minus 2, that's a linear equation, so that is a yes. 2 to the x, that's exponential, so that is a function. Y equals 4, that's a horizontal line like this, so that is a function. X equals negative 3, that's a vertical line, so that is no, that is not a function. Y equals x squared, that's a quadratic, that is a function. And that's an absolute value, that is a function. Looking at number 8 here, so it says a bird flies out of the nest. The graph represents the distance it flies from its nest in meters as the function of time. Okay, so time's down here. So like for example, what does that mean? At 4 seconds, it was about 2.8 meters from its nest. And so at 8.8, it was back at the nest, and at 0, it was back at the nest. Okay, so let's read the questions here. The bird's greatest distance from the nest happens at about 7 seconds. So here's 7. Yeah, that is about 5 meters, so that is true. The bird returns to the nest at 8.8 seconds. That seems about right, close to 9. It's true. The bird's greatest distance from the nest happens at about 2 seconds. Well, this one and A and C both cannot be true. That's false. The bird was closer to the nest from 2.5 to 3 seconds than 2 seconds. So 2.5 to 3 is kind of like right here. Okay, and it says the bird was closer. Yeah, it was closer right here, going to 3 than it was to 2. Between the times of 4 to 6, the bird was flying closer to the nest. So here's 4. And here's 6. So you can see here it's actually getting farther away, so that is false. Okay. Jim is at home. He walks to an outlet mall at a constant rate of 3 miles per hour. His distance from the mall can be modeled as a function of time. Choose the correct graph with distance from the mall in miles on the y-axis and time on the x-axis. So it's got to be increasing because he's getting farther away. So this one is increasing, this one is increasing, and this one is not. So we're down to B and C. Okay, they both start from 0, 0. Okay, so it's at a rate of 3 miles per hour. So the rate, or the m, is 3 over 1. So assuming that the units are the same, I mean like 1 space means 1, we're going to go up 3 and to the right 1, which is more like this, right? Because you can see there's the slope up 3 and to the right 1, so that is B. 10. Select the graph of Beth's earnings that correctly represent the amount of money Beth earns for mowing lawns at $4 per hour. So $4 per hour, so it's got to have a positive slope. All of these have positive slopes. Well, the thing is, we're dealing with money here, so we're not going to be in the negatives. So we're not looking at these ones here. So $4 per hour, so that's 4 over 1. So the slope is going to be up 4. 1, 2, 3, 4 to the right 1. This is up 1 to the right 4. So this is the right slope, and it's not in the negative, so it's got to be C. Okay. Jane is riding a bicycle to the park. Consider the equation that models her distance from her house, where D represents the distance, M represents the speed, T is the time. Find Jane's speed riding her bicycle in miles per hour when the distance from the house is 42 miles and she did it in 2 hours. So I'm just going to plug everything in here. Okay. So the distance, which is D, so 14 equals the M, I don't know that, right? That's the rate times the time, which is 2 hours, divide by 2, and M equals 7. It's technically a rate, so it's going to be like 7 over 1, which is like miles per hour. Right. Unit 1. So what's equivalent? So I'll go ahead and use the distributive property. Watch that negative sign there. Okay. So this is not an equation, it's an expression. So I just combine like terms. So I add these together and I get 2x minus 6y. So that's D. Same thing here for number 13. What I need to do is find the same variables with the same power. So if you look here, I have 2y's, all right, and 2y's and 2y's, so that's all the same. But that's 2y's and a z, 2y's and an x, so that's not the same. So these last two are the same. So I get 3y squared z plus 3x squared y. And so that is going to be B. It's just combining like terms. So now we're going to solve. So now we may have to combine like terms, but as well as add things to both sides, or use our addition and subtraction properties of equality. So I'm going to go fairly quick here. Add a 7 to both sides. Divide by 3. X equals 5. Okay. Now we have to do some simplifying. So I'm going to go ahead and combine like terms. Remember, multiply before you subtract. Alright. Combine like terms. Right. Get all the variables on the same side. I'm going to move them this way. You got some choice there. And so I get 7x plus 21 equals 7. Subtract 21 to both sides. Divide by 7, and x equals -2. C, definitely want to clear the fraction here. So what I'm going to do is I've got a 4, a 3, and a 4. So I'm going to common denominator of 12. So which one of these both turn into, right? So what I mean is 4 is 4, 8, 12, right? 3 is 3, 6, 9, and 12. They both. So that's what I multiply by to both sides. And I technically am multiplying by 12 over 1. So when I use my distributive property, it's only to the numerators. All right? And don't forget to do it on this side as well. Then reduce. Combine like terms. And x equals 1. Now an inequality, so start solving this thing just like an equation. Right, distribution property, oops, sorry. Alright, distribution, addition property, equality. Alright. We get 15. Okay. Coming over here, subtract 4 to both sides. So right now, I just divided by a negative. So over here, I divided by a positive, so I didn't do anything. Just kept going like it was. Oh, sorry, this was a greater than. And so over here, when I multiply or divide by a negative, it flips our inequality sign around. So continue with solving, use my distribution property on this side. Distribution right here. Over here I have to combine like terms. So now I got to get my variables on the same side. I'm going to go ahead and subtract a 6x to both sides. Okay. So I get negative 5x. Oh, sorry, that's a 7. Plus 10. And then I'll subtract 10 to both sides. And like I just as well could have moved all the variables the other way. It's just preference. 18. I just divided by a negative again. So I need to flip the sign. Okay. Alright. So for this next one, it's proportion. So you can cross multiply or clear the fraction. I'm going to do both. I'll do one each way. So for G, I'm going to clear the fraction. So I got a 12 and a 3. So I can multiply those together and multiply by 36 or 12. 12 would be the smallest number, so I'm just going to do that. So I get 12x over 12 equals negative 60 over 3. Then I reduce. And there's my answer. Not too bad. So for this one, I'll do the cross products. I multiply straight across, and I get 28 equals 3x divided by 3. All right. And this one doesn't divide evenly. That's fine. I get x equals negative 28 over 3. All right, last one down here on this page is to solve for y. So there's two variables, so I'm not going to get a nice clean answer like this, but the idea is to get the variable by itself, okay, just like I did up there. So I'll subtract 5x to both sides, and I get negative 5x plus 3. I'll divide by negative 4. Okay. And so I'm going to rewrite this. So what I have here is a negative divided by a negative, so that's a positive. And typically you would see the negative put there in the middle.